Welcome to Lesson 5, Unit 23. Today we'll be using the quotient rule. Let's go back to the board. But the emphasis here is the quotient rule. That is the emphasis. So, Lesson 5, Unit 23. Find the y/ds of the following equation using the quotient rule. 1. Y equal to x squared all over square root of x plus 1. 2. Y equals to x squared plus 1 all over x minus 1. 3. Y equals to the root of x minus 1 all over x plus 1. 4. Y equals to x squared minus 1 all over x raised to the power 3 plus 1. 5. Y equals to x squared minus x plus 1 all over 2x minus 3. 6. Y equals to x all over root x minus 1. Then 7. Y equals to root x all over x minus 2. Well, for today, we'll try to see 1 and 2. And maybe Unit 24, we will do others. But by the guidelines, you can also try your hands. So the rule is question number 1. Y is equal to x squared all over root x plus 1. So what you are going to do, know that this is u all over v. So your u, we can translate this. I've told you in the previous lessons. Translate them. X plus 1 raised to power minus 1 over 2. That should be your first transformation. You should know that your root is half. When you take it up as a numerator, then it becomes a minus. So, taking it up, minus, the root is half. So that is what you are understanding. So, we can also say that this one is u v minus 1. So, if you get that instruction clearly, then we can now say our u is equals to x squared. Our v is equal to x plus 1 raised to power minus 1 over 2. Then we can also say what is our v squared. What is our v squared? For you to get a v squared, you can translate this one back. If you just know that what you have there is 1 all over the root of what? X plus what? Plus 1. That's what you have. So which you can transform. If you square this one, you are squaring the whole. When you say squaring the whole, when you say v squared, means you are squaring the whole. So what you have there is 1 all over x plus 1, which you can translate to be x plus 1 raised to power minus 1. So that's the best way to do this, so that you now know that your v squared is equals to x plus 1 raised to power minus 1. Now coming down to our formula, the y dx is equal to v du dx minus u dv dx all over what? V squared. To minimize space, we can do something like this. So, I don't know that. Let's do this one very well so you know that it's a division sign. for all. So we can begin to do our work. Now, if we say du dx, where u is equal to x squared, it becomes what? 2x. Because you have 2 minus 1 come back as 2x. Then, if you differentiate your dv dx, you are going to get minus 1 all over 2 into x plus 1 raised to power minus half minus 1, which will give us minus 1 over 2 into x plus 1 raised to power minus 3 over 2. So I will define all these rules, then we can substitute. Our substitution will be clear. dy dx is equals to v. What is your v? Your v is simply x plus 1 raised to power minus 1 over 2. Then what is your du dx? Your du dx is simply 2x. Then you have your minus sign with it. What is your u? Your u is simply x squared. That's your u, x squared. What is your dv dx? You go to your dv dx. dv dx is simply minus 1 all over 2 into x plus 1 raised to power minus 3 over 2. Please follow it gently. So if you can do that, your dv dx divided by your v squared, which is x plus 1 raised to power minus 1. I hope you are following. Now, we are now going to do simple expression. Your dy dx simply 1 all over root x plus 1, or 1 all over x plus 1 raised to power half. So minus is your reciprocal sign. 1 all over what? Half. That means root x plus 1. That means root x plus 1. Now we can say that multiplied by better explanation, 2x 1 multiplied by minus, this is minus become plus. So this one is a numerator, become x squared all over. This one is half, which means it goes down 2. And what you have there, this one is root, and it becomes root x plus 1 raised to power 3. Why this minus is a reciprocal? So that's 1 all over. So having done that, then you now know that it's all over x plus 1 raised to power minus 1. So let's rewrite. So you now have dy dx is equal to 2x all over root x plus 1 plus x squared all over 2 root x plus 1 raised to power 3 all over x plus 1 raised to power minus 1. So having done this, you are left with the numerator, the fraction all over fraction. So let's attack this very one. 2x over root x plus 1 plus x squared all over 2 root x plus 1 raised to power 3. Now, let's find the LCM of this. I would have said let us just go ahead and begin to do, I don't want just to give you the answer of this LCM. Let us break it down. Let's assume that we now find out the LCM by using our proper method. If our two factors are root x plus 1 and we have 2 root x plus 1 raised to power 3, and we have to find the LCM of these factors. The first one is that let's use the root. Let's use the root x plus 1. Root x plus 1 will go into this one once. And if it goes into this, it will give you 2 and becomes x plus 1 raised to power 2. So it will go again. You have root x plus 1. If root x plus 1 goes again, it will give you 2 and we have root x plus 1. Then it goes again. You are going to have root x plus 1. This 1 and you have 2. Then 2 will go. You have 1. You have 1. So our LCM will now become 2 into root x plus 1 raised to power 3. So please get this right. I think that is a very important point you need to know. Once you have dissected it, it becomes a free-for-all fight because you are going to get it through with ease. So what you now have, you find your LCM. Your LCM is now 2 into root x plus 1 raised to power 3. So that's what you have. You now have root x plus 1 raised to power 3. So what do you have now? Just like what you did, this denominator will go into this 2 root x plus 1 raised to power 3. If it goes into it, we now see that it will have the power of 2 remaining. 2 root x plus 1 raised to power 2. So what you are going to have is going to be 2x into 2 into root x plus 1 raised to power 2. That's what you are going to have. Plus, this will go into this, you know it will cancel out. It will go into 1. We'll go into it once. So what you are going to have is 1. Then it means you have x squared. Then what you have now will be over your x plus 1 raised to power minus 1. I hope you are following. So if you look at this, this is a power. It's a power root raised to power 2, which means this square will cancel this root. So if that is done properly, you are going to have 2x into 2 into x plus 1 plus x squared all over 2 into root x plus 1 raised to power 3 all over x plus 1 into raised to power minus 1. If you have done that, let's try to bring out systematically without a rush. You are going to have 2x into 2x plus 2 plus x squared all over 2 into root x plus 1 raised to power 3 all over x plus 1 raised to power minus 1. So it's easier here. We can still go further. We have now equal to this, we multiply this, you now have 4x squared plus 4x for ls plus x squared all over what? 2 into root x plus 1 raised to power 3 all over x plus 1 raised to power minus 1. So we can work for that. So draw a line, work for that. We can see the similarities. So let's add it like terms. So we are going to have 5x squared plus 4x all over 2 into root x plus 1 raised to power 3. Now here is 1 all over x plus 1. So therefore x plus 1 will now go up. So you will now multiply whatever you have by x plus 1. So that's what we are going to do now. Let's see how we are going to multiply and see what we are going to have. The x is equal to 5x squared plus 4x into x plus 1 all over 2 into x plus 1 raised to power 3. So let's multiply our numerator. If 5x multiply x, you are going to have 5x raised to power 3. 5x multiply 5x squared multiply 1 is going to be plus 5x squared. Now 4x will multiply x, going to be 4x squared. 4x multiply 1 plus 4x all over 2 into root x plus 1 raised to 1. So your dy, the x, let's add our like terms. You will see that 5x squared plus 4x squared become 9x squared. So you have 5x raised to power 3 plus 9x squared plus 4x all over 2 into root x plus 1 raised to power 3. So that is your answer for question number 1. Thank you. So let's look at our number 2, equation 2, which says y equals to x squared plus 1 all over x minus 1. Follow the rules swiftly. Remember, it's a quotient rule, u all over v. And what we have said, u v raised to power minus 1. So here, our equation can now be x squared plus 1 s minus 1 raised to power minus 1. So that will be your first step. And the next thing you do, your u will become s squared plus 1 and your v become x minus 1 raised to power minus. Your v squared will now become, because what you have here is nothing more than 1 all over x minus 1. So you know, so therefore your v squared is simply 1 all over x minus 1 all square, which is the same thing as 1 all over x minus 1 all square is the same thing as x minus 1 raised to power minus 2, because of the reciprocal. If you have done that, we can now say now that our dy dx is simply what? V du dx minus u dv dx over v squared. So let this always be the bottom of your mind. If you have done this, then go back to differentiating your u and your v. What is your u? Your u is x squared plus 1. So which means du dx is equals to what? 2x. We differentiate the constant, 0. So if you differentiate your dv dx is equal to minus 1 into x minus 1 into raised to power minus 2 becomes minus 1 minus 1. So now all your terms that you need are now in place. So just substitution, and be very careful. So what do you do? Your dy dx is equals to v. What is your v? Your v is simply x minus 1 raised to power minus 1. That is your v. What is your du dx? What is your du dx? Your du dx is simply 2x. 2x. Then you have a minus sign. What is your u? What is your u? You go back. What is your u? Your u is simply x squared plus 1. That is your u. X squared plus 1. Now, what is your dv dx? Your dv dx is into minus 1 into x minus 1 raised to power minus 2. So that becomes your dv dx all over v squared. What is your v squared? X minus 1 raised to power minus 2. So having done that, your work is a little bit easier now. So the meaning of this is simply 1 all over. So you now have that minus 1 all over x minus 1. That's what you have. Multiplied by 2x. Minus minus will give you plus. So this one is in numerator. It goes up. Become x squared plus 1. So if you know that, I've already taken care of this one. This one is your reciprocal. It goes down. So it become x minus 1 raised to power 2. I haven't done that. You now know that this one is raised It's already 1 all over. Yes. So, want to like, you put 1. If you don't do that, say over x minus 1 raised to power minus 2. So now we have come back to looking for our LCM. I won't go to the same process. Use the same process just like the one we did before. If you follow that process, your LCM now become x minus 1 raised to power 2. So, since you have x plus 1 raised to power 2, this will go into this twice. So therefore, 1 will go. So what you have actually is x minus 1 bracket 2x plus. This one will go into this once. What you have there become x squared plus 1 all over x minus 1 raised to power minus 2. So what we need to do now is to bring out and do the simple multiplication. So it's equal to 2x multiplied by x is going to be 2x squared. 2x squared multiplied by minus 1 equals to minus 2x plus x raised to power 2 plus 1 all over x minus 1 raised to power 2 divided by x minus 1 raised to power minus 2. So we can add our like terms. X squared, 2x squared, they become 3x squared minus 2x plus 1 all over x minus 1 raised to power 2 all over x minus 1 raised to power minus 2. Now this is a reciprocal, so it goes up. So your dy dx will now give you 3x squared minus 2x plus 1 all over x minus 1 raised to power 2. Like I told you, you multiply and you have x minus 1 raised to power 2 all over 1. So this one will cancel this. So your dy dx is simply 3x squared minus 2x plus 1. So, thank you. That is your answer. Love to see you in the next unit. Thank you.